All right, let's try these with a couple different dimensions. So, example 7, find the following product. We've got a 2 by 2 matrix here, and we got another 2 by 2 matrix here. Again, we got to make sure we're paying attention. Are the middle two numbers, are the number of columns and the numbers of rows of the first and second, respectively, matrix the same? Sure. In fact, this time, all the rows and all the matrices have the same dimensions. So going through it slowly, I'm going to label a little bit less, but I'm going to kind of emphasize what I'm writing down. We're going to do this first row by this first column. So rows of the first matrix by the columns of the second matrix. So we're going to start with 3 times 1, which gives us 3. And then we're going to have plus 4 times 0, which is plus 0. Next one, same row, second column, 3 times 1, that gives us 3 again. 4 times 1 gives us 4, so we have 3 plus 4. Now we move on to the second row. We got negative 2 times this, now we're working with this first column, so we're doing second row times the first column. Negative 2 times 1 gives us negative 2. And then 5 times the 0, so the second term of this one times the second term of this column, gives us plus 0. Moving on to the second row times the second column. Negative 2 times 1 gives us negative 2. 5 times 1 gives us plus 5. And so you don't need to write quite as much as we did in the last matrix. I would still definitely indicate like what's being added together, especially once we get to larger matrices. It can get a little easy to get lost. So first row, first column, 3 plus 0 is 3. First row, second column, 3 plus 4 is 7. Second row, first column, negative 2 plus 0 is negative 2. Second row, second column, negative 2 plus 5 gives us a grand total of 3. So this is our new final matrix, the product of those two matrices being multiplied by each other. Example 8, we've got some new dimensions here. We got a 3 by 3, 3 rows by 3 columns. This is a 3 by 1 over here. Again, double check, make sure the columns of the first matrix match up with the number of rows in the second matrix, and they sure do. So going through this again, we're making a product here. So I'm going to go through and just kind of take it slowly. We're doing this whole row here by this whole matrix, by this whole column here, which ends up being the whole matrix. So we have 6 times 1 gives us 6. 2 times 2 gives us 4. And 0 times negative 3 gives us 0. So now we've done this whole row by this whole column. Well, now there's no more columns to do, so let's move on to the next row. So we're going to move on to this next row, the negative 1 and 2 multiplied by this column. So we've got 3 times 1 gives us 3. Negative 1 times 2 gives us negative 2, so we'll say minus 2 or plus negative 2 either way. Sorry, that just caught up. Then we have 2 times negative 3, which gives us negative 6. I'm going to do minus 6. And so now we're done with this row and all the rows, all one of the rows in this matrix. Moving on to the final row of that first matrix, we're going to do 1 times 1 gives us 1. 4 times 2 gives us plus 8. 6 times negative 3 is going to give us minus 18. And so this is how we're going to calculate each term or each member of this new matrix. So the top one, 6 plus 4 plus 0 is 10. The next row, we got 3 minus 2, so we're currently at 1. Minus 6 more is at negative 5. Bottom row, we got 1 plus 8 is 9. Minus 18 gives us negative 9. So our final product is this new matrix that has 3 rows and 1 column. So it's 3 by 1. Again, hint, hint, that's where it comes from. 3 by 1, we got 10, negative 5, negative 9.